Welcome to part 1 of 3, Compression Spring Design, a PlanetSpring.com production. A compression spring is a mechanical device in the shape of a helix made from spring wire. It's used to store or release energy. It can also absorb shock and maintain a force between two surfaces. The 5 key objectives for compression spring design. Design the compression spring to fit in your application. Calculate how much force we need at our loaded and working heights. Determine the correct constant. Determine the correct spring material for your compression spring design. Optimize your spring design for maximum life and low stress. Number 1. Design the compression spring to fit in your design so you won't be reverse engineering it. There are 3 main components of a compression spring: outer diameter, inner diameter, and free length. To calculate the correct outer diameter of your spring, we'll need to know the inner diameter of the hole it's going into. In this example, we'll make the hole 1 inch inside diameter. This means my spring's outer diameter can be no more than 0.980 inches to give you 0.010 of an inch clearance on each side of the spring. Inner diameter. If your spring is going over a shaft, you need to make sure your inner diameter is not smaller than the shaft's outer diameter. Let's say my shaft's OD is 750 thousandths or 3/4 of an inch. Then my spring's ID should be 0.770 inches to allow for some clearance. That gives me about 10 thousandths clearance for each side. The free length. Free length is how long your spring needs to be to correctly fit in your application. Let's say your spring needs to fit into a 3-inch long space. That means your spring needs to be at least 3 inches long. Please continue to part 2. What you'll see in part 2: how to determine preload and working heights, an example of L1 and L2, how to test your L1 and L2 values, and the optimal wire type for your working environment. Please go to PlanetSpring.com for part 2 of compression spring design.